my screen.
Hello, doctor.
Hello, yes?
I want to ask you something.
Sure. Go ahead.
Okay. Interesting to see, like Negeri Perlis, small state or area, this maybe still use a lot of water based on the table 247, 241 per capita consumption.
Yes.
Any comment? Okay, thank you.
I don't know how is the usage of water. I mean the statistic capture like that lah. So it depends on the water over there lah. It could be losses and waste that are contributing. Never know, because losses and waste. Okay, the consumption normally, when they supply out, I think they are calculated. This number is calculated at the point of coming out. Meaning how much water is being supplied out from the treatment plant. But along the way, some of the water is being lost and waste. For example, the pipelines may not be fixed properly, or the workmanship may not be proper, so there is leakage. Sometimes pipe burst due to old age and so on. Or sometimes before the water reaches our meter, dah ada orang pakai, they connect illegal connection, they go and use it. Or sometimes the water, NRW.
What we call NRW?
Correct.
RW.
Correct. Non-revenue water. So this non-revenue water, basically, it could be due to that. I'm not sure. Yeah, so if it is due to that, that means people use actually less than that amount, but it is recorded as that amount. Something like that, I guess.
Okay, thank you.
Yeah. Okay, so let's look at a short exercise here. You can see my whole screen now, right? So I think you can see the question there on the top right hand side. We have a situation given to us where we have population in the year 1960. Okay, for a particular area lah, untuk satu kawasan. They didn't mention which kawasan, so just imagine it's for one kawasan. In 1960, population is 33,300%, whereas in 1990, the year 1990, population is 67,300%. Okay. The heavy industrial area and light industrial area for that area is like this, 40 hectare and 75 hectare respectively. Daily water demand at the end of year 2015 is 280 liters per person per day. So this 280 liters per person per day is the consumption rate in the year 2015 for that particular area. And then the question says, assume service factor of 0.99. And then lastly, it asks you to estimate the total average daily water demand for 2015. So, macam mana nak mula ni? How do we start off such a question? So, to estimate the total average daily water demand, actually we are looking at this question here. This equation here. This equation, WD. The total average daily water demand means the WD. Okay. So WD in the year 2015 sama dengan F multiplied by C multiplied by population. So this is population for which year? Anyone? This PN population, we should use population for what year? If the water demand is for year 2015,
here is not, yes, 1990, 1990, I don't know.
okay, you want to calculate water demand for year 2015. For the population demand, you will need to use population for the same year because you are calculating the water demand at that time in the future. So your population should be population in 2015 also. And they give you the C value here already. It mentioned daily water demand per capita is for the year 2015. Alright? Yeah. And then water demand, WDT, water demand from 4 other users will be from the heavy and light industrial area. So this heavy light industrial area is not mentioned for which year, so we assume it is for 2015. Alright, so it's for 2015. Now, out of all this, we have all the values that we need, I think. We have the F value, service factor, assume, so it's assumed 0.99. Good. Then C value, we already have this one. This is the C value, 280. Population. Population in 2015 we don't have, but we are given population in 1960 and 1990. So how do we relate this population to population in 2015 then? We can relate via the previous equation. This equation here, the geometric method of population prediction. This one.
All right.
We can use, so we want population in 2015. Okay, PN is 2015. So equal to population in, let's say, 1990. We use the latest one. Okay, P 1990, 1 plus R to the power of M. All right. And then lastly, for WDT is a daily water demand for other users. So daily water demand for other users, in the question just now, it is other users come from where? Other users will be the industrial area, these two, heavy and light industrial area. So this heavy and light industrial area, the area is given 40 hectares and 75 hectares. Now, where do we have this, the amount of water needed per hectare? This is before that. Yeah. So this one, as a guide, light industrial area will need 22,000 liters per hectare per day, and heavy industrial area will need 45,000 liters per hectare per day. All right. So we can use this and put it into the use this volume together with the area, multiply them, and then you will get liters per day, and then add them up with the demand from the population, and then you will get the final answer. Okay, maybe you all need to capture or take a snapshot of the values here. Light industry, heavy industry.
Yes, already.
Already. How about this one? The geometric method punya?
Yeah, already.
Not yet. Wait. Not yet.
Just snap first because I can only show one page. So I show the last one, I guess. I show the final one. So you snapshot this one and the previous one.
Okay, done.
Okay, anyone else? Cukup Okay, I proceed. So I will show this page. If you need me to scroll back, just let me know. So give you a bit of time to try out this one, try to calculate. And if you have any questions, you can ask me anytime. I'll be here. How long do you need actually?
So the question is, request us to find the water demand lah. Correct ah, doctor?
Yes, water demand. Betul. This one.
For the year 2000.
For the year 2015.
Yeah.
Screenshot ni.
Recording in progress.
So yeah, asking how to get the R value. Okay, like we mentioned previously, R value is a constant for that particular area. Okay, so if the R value is constant for that particular area, it doesn't matter which year it is, right? So you have 2 years given to you there, 1960 and 1990, the populations. So that means R value should, in 1960 to 1990, the R value will be the same as R value from 1990 to 2015. Right? So that means you can use this same equation, geometric equation, but now you put Pn as 1990, P0 or P0 as 1960. Then you will have the values there already. The only value you don't have will be the R. So you rearrange and calculate the R.
It's 1990.
PN is 1990, P0 or P0 is 1960. That means from 1960 to 1990, the projection is 30 years now. M is period of projection equal to 30. Then you back calculate the R.
Tak dapat lah. R dah apa R? Lupa dah. Population or is a constant is this. R is population. (1960) population. Ay, nak kencing pula. Yalah.
you doing?
Calculating.
Still calculating?
Yes, doctor.
Yes, doctor. Very hard to calculate, doctor.
Ya ke? Okay. Tak apa. Just try to continue. If you have any question, want to ask whichever part, just let me know.
Okay.
Oke lah, kita layan ini kelas kejap. Banyaknya.
Okay, do you still need more time? Do you guys still need more time to do the calculation?
We need more time and some kind of example.
This is the example, I'm afraid.
Oh, okay.
Why not we discuss the questions to get the correct answer? Is it possible?
Can. But if some of you still want to try, I will still give a bit more time so that you can try to.
I already get the figure, but I don't know whether it's correct or if there's a million. 250 million an answer. Is it correct?
Yes, I agree with you.
Sorry? How many million?
The answer is around, mine is, I don't know, correct, wrong, 26 million above.
I don't quite remember the final answer. Okay, never mind. You've done it, okay. How about the others? Tengah buat lagi ke? Still need more time? Some people got answer also.
I think the time to prop to explain lah.
Okay, kalau nak we go through the solution together, I'm fine. Anybody still want to take time to do?
Horsepower.
No, huh? Okay, if no, then I think we can go through the solution, no problem. Okay, so we have the information like what we see here. So we need to calculate the water demand, WD. So WD, you know, the equation is divided into two parts. One for the demand from the population itself. The other one is demand from categories other than population. So we focus one by one first. So let's look at the demand from the population. Okay, so demand from population, we need to find out the. Okay, where is it? Okay, demand for population, we need to find out the F and C. So F is given, right? What is the service factor given?
0.99.
Okay, correct. C value?
C value is 280, yeah? 280 or 280? 280.
Okay, C value is 280 liters per. This one. 280 liters per person per day. Okay. Then now what we don't have is actually the population in 2015. Okay, so
Yes.
population in 2015, we need to use the geometric method to estimate. So let's say Pn is population in 2015, and then P0 or P0 is population in 1990 lah. Okay. From 1990 to 2015, how many years is that?
30 years, huh? 1990.
1990 to 2015.
25.
Okay. Yeah, 25 years. So your M value, and for Malaysia, M value period of the projection is 25. But now you don't have the R percentage, right? You don't have the growth percentage. But we know that this method assumes the growth percentage is constant. So that means from the year 1990 to the year 1960 to the year 1990, the growth percentage is supposed to be the same lah. So we can back calculate growth percentage based on these two values here. So we can rearrange this equation, the geometric equation, we rearrange so that we want to calculate R value, and then we put R Pn as 1990 instead, and then P naught is 1960. So I don't know about you guys. For my R value, I got 0.024.
0.0.
Anyone got something else?
My R value is 1.02.
0.2 maybe is a bit too not so precise. I think better put at least 3 decimal places.
Oh, 1.021. My answer is now doctor's is 0.024, right?
Yes.
Mine is 1.021. This
1.021. 1.021. Did you forget to minus the 1 here? The equation got the minus 1 at the back.
the last bit to minus 1. Yeah, forget, doctor. Yeah, correct. So
Okay,
mine
okay.
is 0.021 only lah. Minus 1 is
Answer is
okay.
0.024.
Yeah, 0.021. Okay. Others? Did you get R 0.024 or 0.0237 something, I think? Okay.
0.024.
Okay, similar to mine, same as mine. So R value around here like 0.023 or 0.024, somewhere there. Alright, so assuming you got your R value, then you put it into the population geometric equation again, but this time you want to calculate for P population in the year 2015. So you put it back into the same geometric equation, except that now your P naught or P0 is P 1990, population in the year 1990.
it means 60,000, 300, right?
600,000.
60,000. Yeah. This one.
Yeah, 300. And then times by 1 plus 0.024.
Sendiri padamu.
Apa itu?
25.
Template.
The power now is
25.
Template.
why
So
25?
yes,
Because your n that okay, this 25 here, this power 25 here, if according to the notes, it is period of the projection. This one, m equal period of projection is n minus 0. So period of projection means from 1990 to 2015. So in order to calculate m,
15 or 25?
50.
25.
15.
25.
No.
2015
I mean
1999.
year 2015.
Year 2015 minus year 1990.
90, yes, you get 25. Right.
Oh,
Previously, just now is projected from 1960 to 1990. The one that you used to calculate R. That is why the M value just now is 30. Alright, so population for the year 2015, I calculated is 121,763 persons. How did everybody fare on this one? Okay ke? The value you got, is it close to this?
Yes, Prof.
Lain? Okay eh? Okay, assume you're okay lah, because the steps are shown here. You can go through, no worries. So we can now put P 2015 into this whole WD equation. So WD, we can write it WD, water demand of 2015 equal to F times C times population 2015 plus so WDT just now for the other categories, I split into water demand for heavy industry plus heavy water demand for light industry. Okay, and if you have other categories like water demand from agriculture, water demand from commercial, you continue to add on if you have all those information. But for this question, they only give you the industrial area one, so you just use that. So final calculation for population part is like this. The one is that is highlighted in gray. And then water demand from heavy industry is the area of heavy industry 40 hectares here multiplied by the just now this one heavy industry volume. Okay, the consumption rate 45,000 liters per hectare per day. So like this 40 times 45,000 for heavy industry, and for light industry it is 75 hectare times consumption rate 22,000 liters per hectare per day. So I want to ask you, what is the unit for water demand? What is the unit used for water demand of 2015?
Unit water demand. Liters?
Liters. Okay. Any others?
Liter per person per day.
Okay, liters per person per day. Any others?
Can we use gallon as a Prof?
Gallon kalau gallon dengan cubic meter tu, gallon I think normally we don't use that in Malaysia lah, I suppose. We're using the SI units. Meter cube, you can convert liters to meter cube or meter cube to liters, no problem. But that is not the answer I was looking for. Any other units that you think WD is supposed to be in? If we are to look at the numbers here, okay, say for example the population, okay, 0.99 is a factor. So factors normally we don't have unit, it's unitless, dimensionless, other unit. So it is just a value. And then 280, the unit is liters per person per day, kan? So if liters per person per day, then you multiply with population. Population means the number of people, kan? The number of persons. So liters per person per day multiplied by person. What is the remaining unit there? The remaining unit will be liters per day. Okay, the remaining unit will be liters per day. Similarly, for heavy industrial area, for example, the area is 40 hectare. Okay, 40 hectare. This 45,000 is in what? In liters per hectare per day. So liters per hectare per day, if we multiply with hectare, the hectare will cancel off. So you are left with liters per day. Okay, liters per day. So basically, your water demand will be in terms of liters per day. So this is the answer lah. This is from the population
Water
part.
demand, the water demand in liter per day. Is it correct, Doctor?
In liters per day. Yeah. And this part is heavy industrial demand. This one is water demand from light industries. So you add all the three up together, you will get 37202704 liters per day. But normally in the water supply or water service providers, their circles, because it is not wrong, 37 million, right? 37,202,704. So it's a very big number to write out and pronounce also. So they have another unit which is called MLD. MLD, this one refers to million liters per day lah. Okay, how many million liters per day is supposed to be the water demand?
3 liter. 3 liter per day.
Dia sama je liters per day ni, but because the number is very big, so they want to truncate the number, to shorten the number. So if in million liter per day, so now the number is 37.2 million liters per day. It's just this number divided by 1 million, divided by million. Okay, so which part did you miss out or maybe didn't get? I have shown the steps here clearly, each step. Any questions regarding whichever part that you don't quite get it, this you can ask now. No questions, huh? So I hope the solution is clear. Each step is all presented here. So if you are fine with this, I would like to continue on with the rest of the module. It's okay?
Okay, Doctor. Okay.
Boleh je? Okay. Okay, now we were at the topic of this water quantity relationship with population. So based on the example just now, it is an application of both this equation, the geometric equation, and this total water demand equation. So through that, I hope you guys get like how they actually predict or estimate the water demand needed from a particular area and so on. Boleh, if you want to create water supply group, or are you all in a sewerage group also, or different students?
From sewerage.
If you want to create water supply group, okay lah, no problem. Siapa tolong? Right, let me continue. That is a different topic, so maybe AETC can help with that. Alright, so the relationship with population, we've done that. Now we take a look at the actual treatment of the water. actual treatment of water. So from water taken in from the source, okay, it will flow to a water treatment plant first. Okay, water treatment plant. So this gray color wall represent your water treatment plant. Okay. So inside this water treatment plant, the water will undergo several treatment processes. Each of these blue color word we call one treatment process. So the water will first undergo aeration.